Hi everyone, welcome to this session. So today we will solve some interview question on MOSFET. Okay, and the interviewer will ask you to find the small signal gain by inspections. Okay, what does it means? Are the following. So we cannot write equation. Okay, we cannot write equation, and you will be given that the maybe some cases CLM will be neglected. Okay, channel length modulation will be neglected. That means lambda will be 0 or rds or r naught will be infinite. Okay, you will be given that. And body effect is also neglected. Okay, body effect is also neglected. And we know that to find the gain of a circuit, how we can find that? We will find the overall gm of the circuit and overall output impedance of the circuit. Then we multiply overall gm into overall output impedance, and we find the gain. Okay, so this is the general formula. Okay, but we are not going to write that. We will tell what will be the gain by looking the circuit instantly. Okay, so let's start. Okay, and in this video I am going to write uh, for all the circuits what will be the overall gem and what will be the overall r out. Okay, by inspection. Okay, not writing some equations. So let's start. Now this is our first circuit. Okay, so here we can see that this is a normal single MOSFET circuit, and the input is given in the gate and output taken from the drain, and there is a constant current source load. Okay, and in small signal we know that all the dependent like all the constant sources are zero, like inactive. That means the voltage source will be short circuit and current source will be open circuit, right? For find AC small signal gain. And uh, and in this case we can see that like we will neglect CLM for overall GM, right? CLM, we will neglect channel length modulation for finding overall GM. We can see that to find GM, this is ground, right? This is ground, and we have to find what will be the I out, and this will be open circuit, right? As this is a constant current source, and this will be also ground. So there, if we neglect channel length modulation, that means RDS is infinite. So there will be only one dependent path, right? This will be like this, and this will be GM into VN, and this is nothing but I out as well. Okay, so overall GM here is nothing but small GM. But what will be the R out? So in this, from this node, we will have to look what will be the impedance looking up here and looking down here, and what will be the impedance looking up here. So for like with respect to ground. Okay, like from this node to ground. So we can see that here the independent ideal current source effective infinite impedance, and here looking into this impedance is also infinite if we neglect channel length modulation. So the R out will be infinite, right? So what will be the gain? So gain will be nothing but GM times infinity, that is infinity. But this is not possible, right? Because the transistor can have a maximum gain of like what its intrinsic gain, right? And intrinsic gain is the maximum gain, and this is nothing but GM into R naught of this device. So we have to consider here the channel length modulation. Okay, to find the output impedance. So channel length modulation we have to include here. So the output impedance will be infinite for this constant independent constant current source parallel the R naught of this MOSFET. So this will be nothing but R naught as well. So the gain will be nothing but AV will be GM into R naught. Okay, this is a very easy circuit, but you have to tell in this way. Okay, now for the second circuit we can see that this is a constant current source load, as we are taking the output from here. And what will be the overall GM? We can see that we have to find GM by short circuiting this branch, right, to the ground. And this is the small signal I out. and for I out this will be independent source, so this will be open. And similarly in this case the only one branch is present here for this current, so the overall gm will be nothing but small gm of this MOSFET. Okay, small gm of this MOSFET. But what will be the R out here? R out will be nothing but the impedance looking up here and parallel to looking up here, right? So we know that looking in impedance from the source of a MOSFET is nothing but gm, right? gm, and we are neglecting clm as here in here. Okay, so and the looking down, looking in impedance to the from the node to the downwards, this will be nothing but infinity, right? As like this will be 1 over gm, right? So this will be like as it is a constant current source, so the R out will be nothing but 1 over gm. Now the what will be the small signal gain? This will be nothing but this into this, so this will be nothing but 1. And we know that this is a common structure, it is called common drain configuration or source follower, right? So we know that for a source follower with a constant current source load, or for ideal, common source follower case, the gain is on, right? This will be plus, so the gain of the circuit is plus 1. Actually I am elaborating in much depth, but you in interview you can skip all those parts. Okay, you can directly say that the gain of this circuit will be equal to plus 1, as this is a constant current source, this and constant current source, and we are looking looking into impedance from this node is nothing but 1 over gm, so the gain will be nothing but gm into 1 over gm, so this will be 1. Okay, so you can tell the interview in this way as well. But if you elaborate this, so the interviewer will will understand that you know all these things. Okay, so now let move to the third question. So this is the third question. Okay, now what will be the output impedance, like what will be the overall gm? We have to short circuit this, right, to ground. Okay, and we have to find the overall gm, right? 1 minute. Okay, first we can see that R out. Okay, R out here. So looking into this, the one branch is going to that part and another part is going to that part, and we can see that the impedance looking up here is infinite, right? As this is a ideal current source, and if we neglect channel length modulation, the looking in impedance towards down will be infinite as well. So R out is infinite here. So what will be the gain? We can see that the gain will be infinite as well. Okay, we are not taking the gm. Okay, so but in this case we cannot take R out cannot be infinite. Okay, so we have to include clm here for R out calculation. So how to do the looking in impedance in downwards? So this we know that this is a common structure. Okay, so in this from this node, if we look downward, so this is nothing but a this will be nothing but a source degeneration circuit, right? So we know that the output impedance will be nothing but 1 over gm of this MOSFET into RO of this MOSFET into this RS plus R0, right? So this will be our R out. R out looking downwards, okay, and looking upward is infinite. So this will be nothing but this only, right? And overall GM is, we know that overall GM from for a degenerative circuit, this is nothing but we know that, right? If you calculate this, you will get the same thing. So this will be the overall GM is reduced, right, due to this source degeneration. We know that. So the overall gain also get reduced for a source degeneration circuit. So this will be nothing all over GM into RS. So what will be the overall gain? So this will be nothing but this GM into this R out. Okay. So this will be the overall gain. Now this is very important. Okay. What will be the gain of the circuit by intuition? We can see that if we neglect channel length modulation, so there will be no RDS, right? So there is only one branch to flow this current, and this is a constant current, so this current has to flow this resistance, right? So there is a constant drop of I naught into Rs. So, and this is nothing but V out, and this is a constant part. And we know that for small signal picture, this constant part is AC small signal ground, as this is a V out. So the gain, like V out is like AC small signal V out is 0, and what will be the gain then? So gain will be also 0. So this is a very important circuit. Like I am telling once again, as this is a constant current source, and there is only one branch to flow the current, so the drop across the RS is also constant. So like DC, this is a DC drop. So as DC drop across the RS is constant, so the AC small signal V out will be 0. And we know that for to find, like to find small signal picture, like to draw small signal picture, all the constant sources are inactive. Inactive means if here is a voltage, so this will be short circuited, and if this is ground, so this is like, if short circuit, so this ground is like this, so this voltage is 0 volt, right? So if the output voltage is 0, the gain is also 0. Okay. So what is happening here, is actually, if we find the overall GM, actually overall GM here is 0. Okay. As if this is open circuit, so this will look like this, right? So and okay, I am drawing here. Okay, 1 minute. I am drawing here. Okay. So this will be look like this, right? And we are measuring the overall GM. So this RS will be omitted, right? Because like this is short circuit to I out, right? So the if this is ground, and so if this is ground and this is ground, RS is like RS is dead, right? So we no need to draw it. So this will be the small signal picture, and this is like, this is nothing but, this is 0, right? So this will be nothing but, and the current source is V in into GM, and I out is basically 0, right? Because this is open circuit. So overall GM becomes 0. So the gain of this circuit is 0. Okay. So this is how we can tell intuitively to the interviewer. Okay. Now come to this fifth picture, fifth circuit. Okay. Okay, 1 minute. The what is not responding? Okay. Okay. So this is our fifth circuit. Okay. So in this case, output is taken from here. So for GM, we know that this will be short circuit and there is a small signal current. But here this will be open circuit, right? Right. So what will be the overall GM? Okay. First, let me tell you. So if we are neglecting CLM, so there is no parallel resistance here. So a constant current, there is only one path, right? So a constant current is flowing in this path as well. So the voltage drop across this RD will be I naught into R, right? So this is a constant voltage drop, right? But in small signal, we know that constant thing is always inactive. So and this is a volt. If as this is voltage, so this will be like a short circuit, right? So if this is short circuit and this VDD is AC small signal ground, right? So what will be the output voltage? The output voltage is nothing but 0 voltage. Then what will be the gain? Gain is nothing but also 0. So as a constant voltage drop happening across RD, then the small signal voltage output will be 0 voltage. Okay. So the gain will be 0. And what I am telling was previously, so if we find the overall GM, what will be the picture? The picture will be nothing but RD, there will be a constant like dependent source, but this is open circuit, right? Because of this. So if we short circuit this to find I out, and this is ground and this is V in, So basically this I out is 0, right? So if this I out is 0, the overall GM is also 0. So we no need to find the output impedance. Okay, and here in this case output impedance will be nothing but rd parallel. If this is like channel length modulation is neglected, so this will be this, so rd itself. So the overall GM of this circuit is 0 and R out is RD itself. So the overall gain will be 0. But you have to tell interviewer intuitively what I have said previously, because a constant current is flowing through this RD resistance. So there will be a constant voltage drop across RD. So in small signal picture, this will be short circuited, and as VDD is AC small signal ground, so the V out is also ground, so there will be a V out of 0 volt and the gain will be 0. Okay, so this is also a very good circuit. Now to find the gain of this circuit, so output will taken here, so then what will be the GM, and we are neglected for GM the RDS is infinity. So if RDS is infinity, there is only one path, right, to flow the current. So if only one path to flow the current, and this branch is I out short circuit to the ground, so GM is not, overall GM is nothing but small GM. Okay, but what will be the R out? R out will be R out will be the impedance looking up here and looking down here, right? And if RD is finite, if RD is finite, like RD is very comparable with R naught, then what will be the like looking in impedance here? This will be nothing but 1 over GM, right? And looking in impedance here is infinity, so this will be the overall R out. So this will be nothing but GM as well. So what will be the overall gain? This will be nothing but approximately 1, right? But if we consider CLM, what will be the output impedance? But if we consider CLM, the output impedance will be nothing but, like if RD is comparable with R naught, so then the output impedance will be RD plus R naught divided by 1 plus GM R naught. Okay, parallel infinity, because this infinity comes for this I out, like in depend like constant current source. Okay, so this will be the overall R out if we consider channel length modulation for R out calculation. And we say, I said previously, for GM calculation we always neglect like RDS. Okay, so this is how you can answer. Now third question, seventh question. Now we are taking output from here. Okay, then what will be the GM? We are neglecting CLM. So there is only one branch GM, and this is a source degeneration circuit. We know that for source degeneration, the overall GM is reduced by in this manner, right? GM by 1 plus GM RS. So this is the overall GM. Okay, and what will be the overall R out? R out will be nothing but looking in impedance downward and looking in impedance upward from here. So this will be nothing but RD itself upward. So RD parallel. And we know that if we consider channel length modulation, so the equation is nothing but this, right? We did it previously, GM R naught into RS plus R naught, right? And if we neglect channel length modulation, the R out is nothing but RD itself when lambda is 0. So what will be the overall gain? This into this will be the our overall gain. Okay, small signal gain. Now in this case the output is taken from here. Now if we neglect channel length modulation, and this will be short circuit to find the overall GM, right? And there is only one branch to flow the current I out, right? So overall GM is nothing but GM. But what will be the R out from here? Like R out will be this like looking in impedance to downward and looking in impedance from upward. So if we neglect again channel length modulation, overall R out will be nothing but this RS parallel looking into impedance here. This will be nothing but 1 over GM when we consider channel length modulation is neglected. Okay, so this will be nothing but RS into RS divided by 1 plus GM RS. Okay, then what will be the gain? Gain will be nothing but GM by GM RS divided by 1 plus GM RS. So this will be the gain. But if we not, if we consider, like if we consider channel length modulation, when lambda is greater 0, then what will be the R out? R out will be nothing but this RD plus R naught divided by 1 plus GM R naught parallel RS, right? So this will be the equation. So then you can, like you can replace this R out with this. And we previously said that many times that for overall GM calculation we always neglect RDS. Okay, so overall GM will be remain same as small GM. Okay, so this is how we can find the overall gain AC small signal gain of any MOSFET circuit. Okay, so this is the session. I hope you have learned so many things. And for me the best question was these two. Okay, these two was the best question. Okay, you have to find the I out. Okay, like gain. Okay, and this is a constant source and this is V in, because if there is a constant drop here, so the gain will be 0. Okay, like constant DC drop. And another circuit is here. Okay, another circuit will be look like this. So these two question is very important. Again same concept, a constant drop is happening across RS DC. So there will be a C small signal ground, so the gain, the V out will be 0, so the gain will be 0. Okay, and gain will be 0. Okay, and one thing I wanted to tell, um, and basically here the overall GM goes to 0. Okay, so that the output, like the gain is going to 0. So this is how we can analyze the circuits. Okay, so thank you everyone. I think so you can put your valuable feedbacks. Okay, thank you.